Thank you very much. Oh, I'm online. Yeah, welcome to my little presentation. This year is basically the second year where we demo Iray in Cinema 4D. Last year was kind of a preview because the software was not released yet. This year, I'm going to demonstrate the released version, which was announced earlier this year at NAB in April. In the meantime, we already did a first update of the software, and we are coming out with an update for Cinema 4D R18 very soon. So just to show you where you can find the software if you're interested to try it yourself, if you go to the NVIDIA website, which is the German website at the moment, you can find NVIDIA Iray on the main page. And if you go here, you see a list of Iray products that we already released for 3ds to the Max, for Autodesk Maya, for McNeil Rhino, and also for Cinema 4D. If you are interested to try it, you can easily download and use it for 3 months without any costs. And I'm giving you some reasons to do that. And as a special bonus, we are going to do a live demo in contrast to the other demos, the other presentations. So when you install the plugin, you start Cinema up, you see a new menu coming up called Iray that collects all the features in one menu and points you to basically all the functionality that we have implemented. Otherwise, it's fully integrated into Cinema as you would expect. So it's also here in the plugins menu, of course. You have special entry in the preferences as well. NVIDIA Iray is here. You have special settings. Let me get to the render settings. To talk a little bit, what is Iray? Why do we need another renderer in Cinema 4D where we have a lot of renderers? Of course, NVIDIA is interested to leverage the GPUs as much as possible. And rendering, especially advanced rendering, ray tracing on a GPU turns out to be a very good fit for a GPU because you can take advantage of a lot more cores on a modern GPU. In this system here, or you don't see it, I have one M6000, which is the previous generation Quadro graphics card from NVIDIA, which has about 3,700 cores in the system. So you can use these cores and optimally parallelize your software using these cores. If you look at the render settings, so what does it mean if you have these many cores? You can actually implement software that doesn't make any compromises anymore, that keeps you away from all the fiddling you need to do in traditional renderers to achieve certain speed. Instead, we are simulating reality as much as possible. So Iray is basically an implementation of a ray tracing engine, path tracing engine, that is absolutely physically accurate in all aspects. It starts with physical materials. I come to that later. Physical lighting, environment lighting, physical camera implementations, and all that integrated into the renderer basically means you don't have that many render settings. Actually, you don't have any render settings in that sense. Nothing to worry about in your renderer. The renderer takes care of producing the final quality. You have a little bit of control when the renderer should automatically stop in case you're fine with the quality that you've achieved. You see here these end criteria. I've set it to 5 minutes at the moment. So for this graphics card, we're going to see what 5 minutes means in terms of quality. You have options to set certain number of iterations. And we can turn on a certain special effect as caustics. This is typically done in traditional renderers using another render engine. We do it all in one. Lighting effects through water, through glass, something like that, automatically computed. The only relevant render option is maybe the path length. That is similar to the trace depths in other renderers. As you can see here, I have set it to 20. If you compare that to traditional renders, it's extremely excessive. Other renderers set it to maybe 1 or 2 or 5, maybe at most. That means you get global illumination quality out of the box without tuning any other settings. Yeah? And of course, we need some kind of firefly filter. We come to that later. That is to fix some issues with the algorithm. So that's pretty much it. We have some post-effects filters here. You can also use motion blur. But motion blur is an effect that you can use for final frame rendering. So I'm leaving that off for now. The only other option you have here is an image filter, where you can tune your quality of the final image, and some other effects like a bloom filter. We also have implemented support for render passes that fall out of the renderer immediately, so there's no extra render pass needed. It's just one render, and that spits out these number of passes. Interesting thing is, this is controlled by so-called light path expressions, and I'll come to that later. That gives you a very great flexibility to define your own render passes if you're interested. So that's it, pretty much. That's the render settings. Otherwise, let me just start with something. You create your object. You render with a picture viewer. That is your typical workflow in cinema. But the real benefit of using the GPU is interactive rendering. So we have implemented a live render window. You've seen that probably with other render engines. You can use that here. You can dock it somewhere in your layout. And whatever you do here, it's immediately reflected in your live render. You can work as you like. Let's say you create an array of that. However you model your scene, you do something, you animate it. You see it even animating in your render. The performance of that animation here, the performance of that live render, is determined by the hardware that you are using underneath. So you could use CPU, you could use GPUs, and the more GPUs, or the better the GPU is, the faster this rendering works. So that's not very fancy scene, so let me open something more elaborate to show you some of the features. So I have the live render window open. It's stopped automatically because it noticed that there's a new scene coming. So this is a quite heavy scene already. It's only indoor. There's no outdoor lighting coming into the thing. And the only light that is created there is from materials that emit light. So there's no actual light source in a scene. That's only materials that have been turned into emissive materials. So after a few seconds, you see already a preview of what you are going to get in the end. You can manipulate your scene. And even on that single GPU, you get a pretty decent performance here. You can, I have in that scene, I have actually 2 cameras. You can switch cameras quickly and see it updating here immediately. What you also notice here is a little NVIDIA icon next to the camera where you can control Iray specific settings for your camera. In that case, you can control the exposure because that was a kind of dark image, almost interactively. Go back to the other camera. So this is the way you can work if you have Iray and a decent GPU. In addition to that, as I said before, you have all these passes that we talked about before already computed. So you can, let's say you can turn off the indirect contribution for your render. That is like a traditional render where you only see one bounce of light. This is all the indirect light. This is after the first bounce. So whatever you can imagine as a pass, this is a preset of passes here, specular passes reflecting emission. There's all these elements that actually emit light. And of course, you have something like DAF. And that's, of course, everything is interactive. Yeah? So if you're fine with your rendering, you can let this live render run. As I've shown you before, there is a stop criteria, so it will automatically stop after 5 minutes, because I typically find with 5 minutes render. You can stop the live render with this button, do your manipulations. If you have some excessive modeling tasks to do without to spend all your resources on that, and then you later on you just enable that again. It picks up the status of your scene and renders it again. You can even save this image that you've created here out to a file if you want, but typically you go to Picture Viewer and render your finals. If you, let's say you've seen that here, you're interested to see some effects of the render settings, you can actually do that. Whatever you do here in the render settings, let's say reduce the path length, it's reflected in the render directly. So whatever you do here in your settings, you see that. I mean, that's a crazy setting, but just for showing you that it actually works. So whatever you do in your render settings is actually reflected in your render. Regarding the multipass, you see these pre-selected passes here that are also here as a preset, but you have the option to create custom passes, and that is using a special kind of a language where you can write your own expression, and that expression allows you to select elements in the scene or select effects in your scene that you want to have in your pass. And that pass, as soon as you've created that, will be added to the list here, and you can render it out. I don't have an example of that, but you could use that, for example, to select certain objects or to select certain lighting elements in the scene and get a pass only for that specific light. That is a very common request. So, as you've seen here, we have these camera tags that implement special features. I come to that with another scene. Just to mention the tone mapping here. This is basically your physical camera that allows you to tune your camera settings and your film settings interactively. Like the gamma, you can do that just live. whatever you do here. In the background, the image that is rendered is an HDR image anyway, so all these things are basically post effects that are applied directly to the rendered image, so it doesn't need to be re-rendered. So that's it for that scene. That explained a little bit the interactivity, how that works. You can close the window. I close that scene and use another scene to show you some more effects. So we do a similar thing. This is like a product design scene. This is a running shoe. The scene is already set up with some IBL image. I'm going to show you some other effects. So as soon as you see that here, it's almost a finished render after a few seconds. Of course, it's a simple setup. It's just an IBL around this shoe here. But you notice some special thing here. I've actually cut off half of the shoe. So that is a so-called section plane. This is a render time effect. It's in here. If I move that a little bit, or even further. So you can cut away certain elements of your object. Actually, it's not this. Okay, takes some time to update. You can cut away elements out of the render without actually creating geometry in your scene to cut off certain pieces of the geometry. It's just a render time effect. Of course, this is all interactive. I've added a little bit of depth of field here, and even in this, with this single card here, you get basically final quality after a few seconds. So if we take off that section plane, get the full shoe here, we go to the camera, we have our depth of field effect, make it a bit more prominent. So you can imagine how quickly you can achieve final quality with this kind of rendering. We can also go here and adjust the exposure as we wish to exaggerate the effect. So that brings us a little bit, as we see here already, to the material system. And I'm going to use another scene for that, because the material system is a bit special in Iray. We had to invent a new material system, and I'm going to explain why. So let me close that scene. And open something small, but great to have for explaining a little bit the material. So we have a little Lego kind of object here. You see a little bit of the distortion of the IBL, but this is something you can adjust with some IBL settings. So in this case, I'm using an image to illuminate the scene. The materials that you see beneath here look like cinema materials. All these swatches look familiar to you, to a cinema user, but actually what's behind it is our own so-called MDL materials. So we developed a material system that allows us to share material descriptions between renderers. The reason was NVIDIA itself delivers several renderers, and we don't want to invent shading for each of the renderers again. We want to be able to share one material system, one material with the other renderers, and they should be physically plausible from the ground up. And you take one material from one application, put it into another application, and it renders exactly the same appearance. Even if the renderers are not capable of doing the same effects, the material is guaranteed to be the same. So from a cinema perspective, it looks like a regular cinema material. You see parameters. You see even a little description here. I've took one of the materials that NVIDIA has developed. They are called V materials, verified materials. So we've published about, I don't know, 200 materials on our website. You can download these materials and you can basically plug them into your Iray capable application at the moment. But we are working with vendors of other renderers to support this material system. What it makes it so attractive is basically the physical principles of these materials. So going away from all these shading tricks, doing materials where you don't affect your rendering engine. You really only control material properties. Typically in shader systems, you have controls to, I don't know, affect the sampling of the render or something like that. So that's not the case here. That allows to use the same material in other render engines because it doesn't carry any render-specific information. So if I pick, let's say, this site here, open the material, make that blue, I don't know, something like that. You see the swatch updating. The swatch is also using Iray for rendering. And now it's competing a little bit with the live render because it's one single render engine, but you see the effect almost immediately. You can even tune translucency up so you get some more translucent effect. Let's go closer. So from the usage standpoint, it's exactly the same as you would expect in cinema for any other renderer, right? So the good thing is you can even write your own MDL materials because behind it is a text description. You can write it basically down. We are working with other vendors to implement an editor. For example, we are going to support algorithmic substance designer materials with MDL, so they will spit out MDL from their material graphs. And we are going to render that directly because they generate MDL content. And that makes it a perfect fit for algorithmic substances. So substance is also in cinema now. So that seems to be a perfect link to use these materials directly. So what you can do after you've fiddled with these parameters, you can actually take that setting here and export it as your own material preset. That will be exported out to the disk, and then you can take that file, it's basically one file, and import it into any other application, and you get exactly that material in the other application. Let's say Iray for Maya. So we've made sure that upon installation of the plugin, we also install a so-called material hub. And that material hub provides all the necessary infrastructure to exchange materials between the applications that we are currently supporting. Because there's some specifics in Cinema or in Maya that need to be carried over. So I'm not going to do that here, but leave that. So to show you what the vMaterials mean, you have here above in this material editor, you have a select material button. And that brings up a material selector window. And in that window, you see the so-called vMaterials that I was talking about. We've actually created a ton of materials that should basically please the needs of a lot of cases already. I'm just clicking through that here. So you can start with lots of stones, with any kind of architectural materials that you typically need. Then we have a design section here. You have glasses, gems, whatever. So you see, this is already kind of a good basis to get started. If you import your scene that you've basically adjusted to a specific renderer, the first thing you need to do, you need to reassign the materials, which is unfortunately a tedious task. Nobody wants to do that. So what you could do, you take one of these preset materials because they cover a lot of cases in the architectural and design space. The other thing is, and then I'm coming to that with the next scene, we've implemented an automatic conversion of cinema materials to MDL in the plugin. That makes it a lot easier for you to start using Iray. So let me take that metal here. So it's updating that, and we'll see if it actually renders our Lego. You see also the swatch here beneath is updated. So it's all integrated in Cinema editors, as you would expect. So now I just need my model to update that. And maybe apply it again. Something is happening. Yeah. So regarding MDL, that is MDL itself is a spec, basically. It is a spec that we published. You can download from our website. You can, if you're interested, you can even implement your own integration of MDL materials in your own rendering solution if you're going to write one. So we are working with other vendors, as I said, to implement support for MDL. You can even use an existing MDL and layer it with more effects directly in Cinema. So let's say I have that yellow, it's called yellow, that material here, metallic. Unfortunately, we don't have a typical shading graph editor, yeah, like a shading tree or something like that, because that isn't a perfect fit for this kind of layering, where you construct materials by layering effects on top of each other, like you would do in the real world if you would create a material. But you can actually create layers on top of existing materials. You just go to NVIDIA materials, and you have these so-called core definitions. Core definitions is like building blocks that provide you these kind of layers. So you see some effects like cutouts, emission, that you add on top of your existing materials. And I take this metal that I just created and maybe do a clear coat on top of that. So what happens is you see this little swatch here. This is the clear coat layer, and in order to link, it's a layer above In order to link that to my metallic, I just drag and drop the metal here, which is the base material. And now I have basically a layered construction of these two layers within the cinema system. It's not perfect, yeah, because you see two nodes. This is actually the layered version, and this is the base layer version of that. But at least you are able to do some kind of layering with the current approach. Later on, if the substance works or so, you get more better editors to do this. But at least we provide a way to create layers. So if you now apply that to that object here, unfortunately, I guess you don't see much because the metal was already kind of shiny, but let's see. So you can go into your coding. The coding itself has its own properties. You can, you can even apply a bump. I don't know, reflection roughness is 0 already. That's quite nice. So you can make it a little rougher. That's just controlling the coating layer. Yeah. The base material. This here has its own settings, right? So if I use the base material's color and make it, I don't know, some yellowish again, I should see it updating again, maybe. Sometimes you see it's not automatically picking up my changes, but that is a tricky part of the plugin, and all the cinema developers maybe know that. It's not easy to figure out if you change something in the scene that you get notified automatically of the changes, but we are working on that. So it should be interactive in all aspects. But as you can see, even if you have kind of displacement or scratch layer, dust layer, you do it like that I just showed you. So you can create more complex materials quickly and easily out of these base components and then save it out as a preset for either later use in your own cinema, models, or in other applications that use Iray. So that concludes my talk about MDL. I don't know if you have any questions regarding MDL, because that's a major part of the physically based rendering in Iray. Okay. Just go back to the original scene. So you see there's even a translucent or even a glass-like material on top of that. That takes some time to resolve. But the longer you let the render run, the better the quality will get. This is the kind of progressive rendering that you see in all these renderers these days. So the good thing is that all these pixels that have been computed in the beginning, they are not lost. So everything that's computed is also taken into account in the final image. But you get very quick previews in almost final quality. So let's look a little bit at the lighting in a physically based renderer. For that, I close that scene. I'm using a scene that should be very familiar to those who use cinema, because it's an example scene that comes with cinema, staircase room. And now I'm going to show you what's the difference if you render that with physical render compared to Iray. So this, I just took the scene pretty much as is. So I didn't even touch the material system. And just to show you what you get if you take an existing cinema scene, the plugin is trying to do most of the work for you already. So it tries to convert the materials that you have, basically only standard, cinema standard materials, to MDL materials underneath. And you see already after a few seconds, you see basically your a preview of your final image in a very decent quality. No need to wait for any pre-passes or something like that. You can already judge the lighting quickly. It's actually using also the sun and sky system of cinema, and I can even go in here and adjust that and see it updating in my live render. Now, wait a second. Just make sure I've should select the sky system, right? So otherwise, that wouldn't work. So let's move it a little bit. You can very quickly get an update of your image. You see that. What's going on underneath, because it's not pure MDL, it's translating the sun and sky system of cinema live to MDL underneath and rendering that. But as you can see here, almost final quality after a few seconds. I've actually created few MDL materials. I just took one of the, I just replaced the floor, for example, and the curtain and some of the metals. That tells you, you can basically have your cinema materials side by side with MDL materials. The cinema materials will be converted live. During rendering, the MDL materials already exist in MDL language, so they are directly rendered. So let's go to the sun and sky system. I'm not going to, what you could do, you could take that sun and sky system and use Iray's own native so-called Iray environment, which is basically very similar in terms of functionality to Cinema Sun and Sky system. So I'm not going to do that because what we see here is already perfect for the purpose that we want to achieve. You can even use the familiar controls that you have in your Cinema Sun and Sky, like time and location. And click that now and click through it. What I'm going to do now is turning it into nighttime. Let's see if that's possible. Yeah, okay. Wow. So now I left this on purpose. What you notice in that scene, there's some light coming through the curtain, and that's exactly one of the issues with converting materials that somebody created, because that is a luminance channel in the material. We can pick that carpet, this is this here, check the material, and somebody, I don't know, this is actually coming from cinema. Somebody turned on luminance. Luminance in the physical world means emitting, and so it's actually generating lights. And that's a typical thing with, if you've set up your scene to achieve a certain lighting effect, that typically was necessary with traditional renderers. You tweak something because you're not fine with the result. With Iray, you don't do that. Yeah? So I turn it off. Now it should be, this is actually nighttime. And if you look closer to that, there is some light in the scene. And in order to reveal that, I've created another camera. This is the lamp. The lamp is actually turned on in that scene. Now we're moving to that camera. And now what I also did, I actually have this exposure control here on that specific camera set to a different exposure, to exposure at nighttime. So now you see the effect of that light. that you have not noticed before, although it was turned on. So that's one of the beauties of physically based rendering. You don't take care of the finer details of the lighting. You just turn it on as you would do it in a reality and let it render, and then select your view, select your exposure. If I go back to the original camera, I could also go into the original camera, go into tone mapping, and dial the exposure down to reveal that lamp somewhere in the corner. There it is. This is all live, what I'm doing here. This is rendering live. Yeah? So I'm not... That's a bit too much. Okay. So I don't know how many people of you are familiar with this scene. I've tried that scene with other renderers, and that's just amazing in comparison, what you could do here. So just coming back to that curtain problem here. So if you have materials that have been tuned for a certain effect, that could be a problem, but you typically, I mean, sometimes you don't notice that. I was able to notice that through this change of the lighting. What we really like to have is that you can take your existing materials, cinema materials, and convert them basically batch-like to MDLs. And that's something we are going to offer in the next version. Right now, it's all underneath. You don't see the outcome of the materials of the MDLs. You just notice it in your rendering. So that is one of the beauties of physically based rendering, which is Iray is specifically a perfect fit for architectural scenes, for product designs like that, where you don't have the knowledge how to tune your renderer. You don't want to do that. You just let the renderer do the work. And if you are not fine, if you want to achieve better performance, for example, you spend a better GPU. But other than that, all your workflows, the typical workflows, where you use OpenGL preview for modeling, and then you wait some time for your final render, that will change dramatically because you render basically live your final results almost instantaneously. So, okay. Let me check the time. Okay. I have some minutes left. So, I have another scene coming back to some new features. So what I showed you is basically existing in the current plugin. So if you download the plugin, you have all this functionality that I just showed available, and you can use it. What I'm going to show now is coming in the next update. And we are looking for you for feedback, if that makes sense. I mean, some aspects certainly make sense, some others is up to the user what they would like to see or not. So I've used a familiar model to some of you. Just render that camera. This is the bubble ship from the Oblivion movie. What I want to show you is basically the first implementation of support for VR camera, that you can actually render out VR 360 content using Iray. And what you have to do you use a new feature in the camera tag. So it's very simple in that aspect. You just create a VR camera, basically. It's a regular cinema camera that you would create in the Create Camera menu. I did that already. It's called the VR camera down here. And if you go into the VR camera settings, you see a new lens tab. And I selected spherical. So we implemented support for custom lenses. And that is a 360 lens now. If you have that in your camera, you place the camera. I placed the camera actually on the seat of the pilot. And now we can even render that 360 view in the live render. So I just select the VR camera. Of course, our perspective looks a bit strange. Let's see. So what you see here now is the 360 rendering of the pilot capsule. So you can create any 360 content of your environments, of your virtual set, using this new camera mode. You can save it out. You can even do stereoscopic renderings, although stereoscopic is not perfect because not supporting moving stereoscopic. But static stereoscopic is very well possible with that. So just by adding this new lens type here in the camera tab, you have access to VR output directly in through Iray in Cinema 4D. You can save it out. You can also render that through Picture Viewer, of course. Let me go back to the original camera. Even in that mode, you see it's all interactive. So whatever you do, even the 360 view is all interactive, rendered live. Another feature that we started to implement is the live render is a nice implementation, but what we really like to have, or most people like to have, to go into the viewport directly. So I heard that the cinema people working on something that renderers could actually render into the viewport. We figured out a way to do it right now. So you can actually enable Iray directly in the viewport. It's kind of a post-process that it's composited on top of the OpenGL view. We'll see. Maybe you should turn off the live render. So you see the OpenGL handles here. You can actually manipulate directly. You can use the controls that you're used to here. We made it a little low res so that you get some interactivity that you can control here. So I set it to 50% of the final resolution. You can even go 100% if you like. But you can pick object as before. See it moving. So this is kind of a preliminary viewport rendering. I guess with the next version of Cinema, it will look a lot better than that. But that will be available in the next version. And we'd like to get your feedback if that is something you'd like to see. You can even go back to your four-sided view, do your manipulations here in that little window. So get rid of the live render window because that is basically giving you all you want, right? You can do your own window layouts and get your live render. You even see these hubs coming up. So it's all there what you would expect from your viewport anyways. The only hiccup is you see a little bit of the OpenGL is affected because I have only one graphics card that is doing both OpenGL and the render. So that is the only tricky thing. So going to disable that again. And so these are the two new main features coming with the update. End of September, this is the viewport integration of Iray and the VR camera. We are planning another VR update in a few weeks that will provide full stereoscopic VR output rendered through Iray. And that is even accurate. So that is not far away, but this version that we are going to release end of September will come with this initial 360 view output. NVIDIA is actually delivering updates to the plugins automatically. So if you have installed the plugin, you have this little icon down there. This is the NVIDIA License Manager. And the License Manager tells you which NVIDIA products you have installed. But not only that, it's actually checking if new versions are available and downloading new versions and installing automatically if you want. You can disable it, you can enable it, but this is something separate from the actual plugin. As you can see, there's the vMaterials registered. Iray Server is another product that I'm going to touch a little bit. So all NVIDIA products are collected in that license manager, and you get an overview of the versions that you have installed and the license conditions. So one thing that I have not touched a lot today is the remote rendering capabilities, because we are going to come out with a Mac version of that plugin. But unfortunately, current Macs do not have so much NVIDIA GPUs in it. So you can use it on a CPU. It's the same workflow. It's actually even the same results on a CPU, just slower. But you have the option to connect to a remote GPU system. And we call that, we have two options, streaming and queuing. So queuing is a typical batch rendering system that goes through a little server, batch server. I've installed one here on the system, and you supply your job to the system. That could be your Windows machine in the company that has, I don't know, 4 GPUs in it, and render there. Get it back through your Mac, for example. That is the old way of working. This is the typical render farm or something like that, batch render option that you have. We even have a button here that brings you directly to that. Okay, it's not started up. Let me just do that. So I've installed a server setup here on the local machine. It's not perfect, just to show you how that looks like. So you have a little control web browser panel. And here, this is like you would expect. You see a queue of your jobs. You see, actually, I don't have any jobs created now. You see the images that you've rendered. You can download from there. And so that's a typical batch render setup. The other thing is you actually want to accelerate your interactive rendering experience. And that we call that streaming. So it is possible to use remote GPUs in your live render window. In order to do that, you have to have a system that supports that. Yeah? So we have one in NVIDIA internally, but you can have your Iray server, the software that I said before, to actually support that interactive mode. You need to enable that in the server, and then you can use that dialog. And if you do that and connect to the system, it looks like you're rendering locally, but you're actually rendering on a remote system. If you're interested to hear more about that, I'm available at the booth. But that concludes my talk about the plugin. Thank you very much for attending. Just to recap, we plan to come out with a version that supports Cinema 4D at 18 end of September. That will come also with the Mac version. That will come with VR camera support and viewport integration. Otherwise, please feel invited to come to the NVIDIA website and see updates about our products. Thank you very much.